Hi there, welcome to your own series where we do one JEE Advanced previous year question every day. Drop and drop makes an ocean. Let's create an ocean of questions. Let's get started with day 2, question 2. Look at this. This is a match the column question, JEE Advanced 2017. There are 2 questions based on the same match the column and there are 3 columns. 3 columns is the thing of JEE Advanced papers. So I'm sure column 1 and column 2 practice you already get in JEE Mains. That's something that you are acquainted with. The fun starts when you have 3 columns. Once upon a time there were 4 columns also, a question that I'm planning to take up going ahead from atomic structure. Well, so these are very interesting questions. So first I'll try to give you a hang of both the questions together. Look at this. All you have to do is find the correct match. So this is first part of the question and second part of the same question. Like 2 questions, match the column is same. Okay. So let's get started. This is kind of like match the column comprehension question. Okay. Let's see. See, the moment you see toluene, you know that toluene has this particular hydrogen which if you do the moment I see Br2H nu, I know that this H can be removed in such a way that you get a benzyl free radical, and they can be at the place of hydrogen Br, so they can be substitution. So I can go with 1, along with that 1 we can go with second, and along with the second we can say substitution. So 1 to an R I can already see as a part of our answer. So D has to be the correct answer and we are done with the first question already. Nonetheless, let's still, if we are not able to figure out, we'll go to the next one, acetophenone. So you know how the acetophenone looks like. This is your acetophenone, COCH3. The moment you see this COCH3, I'm sure you're reminded of the halo form. So what are the reagents used in the halo form? NaOH plus X2. In our case, Br2 is given. So yes, with second we'll go with first from the column 2, and this is nothing but halo form. So we'll go with the S. Okay. So you can see that another one is down, which is with second we will go with first from the column 2 and we'll mark halo form. So second, first and S. So C cannot be your answer any which ways. If you see benzaldehyde, either Cannizzaro reaction should have been there, for which you require NaOH plus NaOH in the basically concentrated form, 50% NaOH. That's something which is not given. So that is ruled out. If you see halo form is done, the Friedel-Crafts substitution is also done. NaOH plus CO2, the moment you see this, you should be reminded of what? Kolbe-Schmidt. So I've told you, you should remember Kolbe-Schmidt and Riemer-Tiemann in a couple, in a couplet, like 2 reactions together. Like for example, Wolff-Kishner and Clemenson reduction, you should remember together. Similarly, you should know Swartz and Finkelstein together. Do you understand? These are the reactions you should know together. Similarly, Lindlar catalyst and Birch catalyst you should know together. This will help you enhance your understanding. So is with the formation of the salicylic acid and salicylaldehyde. Salicylic acid, Kolbe-Schmidt, you use NaOH, CO2. So what is salicylic acid? I hope you remember, right? This is your salicylic acid. You have OH already attached and COOH. The source of the COOH is CO2. The electrophile used here is CO2. So what you get is salicylic acid. First you get the salt of the acid and then the acid after protonation. So this you get from CO2 and the reagent given is NaOH, right? From phenol. So this is, can I say carboxylation? There is an addition of carbon dioxide. So of course with fourth, we can go with again the fourth of the column 2 and can mark carboxylation, which is Q. So we are done with the 3. Already the answer for the first one is out. Let's see whether all of this, and we are still not done with the column 1/3 part. and the third of the column 2, and of course if you see condensation from the column 3, that's still left. So by default, third, we will give it with the third of the column 2 by default, okay? And this is the best part of match the column, until and unless not multiple things are correct. So if you see here, our answers second, fourth and R, second, first and S, so this is also not correct. Fourth, third and Q, fourth, third and Q, no, fourth we are getting, so this is also not correct. Third and P, okay, third and P by default, yeah, by default it is coming out to be correct. But logic we still have to discuss. So third and P, by the virtue of eliminating the others, we can say C was right. But nonetheless, 1 in S, 1, second in R. So of course, that is also ruled out. You know answer should be C. But now let's see how the reaction is happening. We need to know the mechanism for this reaction. So you should know that benzaldehyde, this is an aldehyde with no alpha hydrogen, correct? When you're reacting it with the anhydride, the moment you see anhydride with the salt of the acid, something which is not in your JEE mains but is a part of your JEE advanced syllabus, Perkin reaction should strike the doors of your mind. What happens here is, I'll just show it to you. What you start with is something like this. You start with an anhydride, and you have the potassium salt of acid, so O minus, this is capable of taking H plus, it's a conjugate base. So let me write anhydride like this, such that one hydrogen is like this, where O minus can take this hydrogen to form an anion which looks like this. Now once your anion is ready, next step is crucial. Now make use of the benzaldehyde. You know it is famous for nucleophilic addition reaction, benzaldehyde, and that too very reactive towards the nucleophilic addition, and the nucleophile is now ready in front of you. So this comes here, and what you get is C, O minus, this H is here, this CH2, C double bond O, O, C double bond O, CH3. So this is ready now. Okay. Now what is happening is there is this O minus, which is a nucleophile, which can certainly see there's a carbonyl nearby. So that you can feel how close the carbonyl is, let me draw it like this, that this CH3, let me put to the other side, so that you can feel that, okay, the carbonyl is close. Now you can feel the intensity that yes, the next nucleophilic addition reaction is possible, such that you end up getting this. Check this out. So you get a ring now, O minus, CH3 here, this O, C double bond O, CH2, and this H is as it is. Okay. Now there is something which is very interesting happening. Check. What can happen is, you can get this carbon I'm drawing out here, CH, O, CO, CH3, this can be cleaved, right, such that this O minus, the minus comes back here and this bond breaks, and what you get is here CH2, C double bond O, O minus. So you get this carboxylate anion once again. Now once you have this, again observe what is the possibility. Do you observe there is a very acidic hydrogen right here in this intermediate? So if I write this particular hydrogen like this, or let me show it in such a way that it can easily be abstracted like this. Now there is still CH3COO minus in the solution, right? So this can abstract this alpha hydrogen also, such that you get another anion. So what anion you get? I'm drawing it here. So you get an anion, or let me use some space here only, so that what you get is this. Look at this. CH, C minus, then you have one hydrogen already attached, C double bond O, O minus, and OCOCH3 as it is, right? So you've got one minus. This minus comes back here, and this CH3COO minus leaves, hence acting like a catalyst, such that you get cinnamic acid. This is what is cinnamic acid. Check this out. This is cinnamic acid. So you have CH double bond CH, COO minus coming up. Cinnamic acid is what you call it. So please be careful. You can directly do Perkin reaction like this in such a way that you can write it in this format, right? CH3. So write the two hydrogens of the CH3 like this, CO, OCOCH3. So we call it box method. Just remove water from here and combine the two so that you get C double bond C, C double bond O, and then break it from here so that you get O minus Na plus, which after taking H plus will give you this particular cinnamic acid. Basically a condensation has happened, hence the name Perkin condensation. Okay, so it was an interesting question. Add on to your named reaction list. Do all the steps that we have done here on your own. So one step I have just surpassed one particular molecule, so write it nicely. Do it on your own, write it down on your own, and once you write it on your own, you will see that it's a very simple reaction. So Perkin reaction added to your list, Perkin condensation, to the holy book of the named reactions, which I told you is very important. See you tomorrow with another question. Bye-bye.